If you want to recirculate the air from any dust collection system back into the plant, you can do it, but it requires a number of additional considerations that you have to review. So with woodworking, the biggest thing you have to consider is fire safety and combustible dust safety. So specifically, when we say combustible dust, as we mentioned earlier, it's actually two things. It's not just do things catch on fire, but it's also explosions, and both of those can happen with woodworking dust. So if the dust, as an example, if you're sucking the air in and there is a fire somewhere between the pickup and the dust collector, right? We have to have some kind of system that stops it and breaks it so the fire cannot get pulled into the dust collector. In the dust collector, the main hazard is it exploding. So that's why we have the explosion vents on the dust collector. A fire is also bad, but explosion is much worse. So most of the requirements have to do with stopping or safely venting out an explosion. In most cases, if you exhaust the air out, the main hazard is removed. If the dust collector is outside and you're exhausting the air out, you pretty much just need three things. You need a explosion isolation valve that stops the duct, the explosion or fire from going backwards through the duct into the dust collector, or back from the dust collector back inside the building, right? Then you need the explosion vents on the baghouse, and then you need to exhaust it out, okay? And if that happens in an explosion or a fire anywhere in there, it will not propagate and become worse. If you want to recirculate in is where the problem comes, because now if there's an explosion in the baghouse, let's say, and it's running, you have the fan pulling air out of the baghouse and then pushing it back into the building. There's a fire or an explosion anywhere upstream, the fan will take it and push it back into the building. And that's why it's tricky when we have woodworking. So we basically have to add another layer of fire and explosion isolation on the ductwork that goes back into the building. So it's not a big deal. Sometimes we can use an abort gate, a high-speed abort gate. Sometimes we have to use a combination of a fire break shutter and an explosion isolation valve that will slam shut, but we can do it. If you put the dust collector inside the building, that's kind of related. It's not exactly the same of recirculating, but if the baghouse wants to go inside, it can be done. But again, it just makes things trickier. You generally have to have the explosion vent go outside, and you can't have a very long connection. So you'd have to put the baghouse right up against an external wall, cut a hole in the wall where you can have the explosion vent ducted just a couple of feet, like 2 or 3 feet through the wall so that it explodes and vents outside in case something happens. You could also put it inside anywhere if you want, but then you'd have to have a flameless explosion vent that would let the pressure out while snuffing out the flame front in the event of an explosion. So putting it inside and or recirculating the air back in for fire safety, it can be done. You just have to have a bit more equipment. The last thing with recirculating the air is for health and safety inside, kind of also related to the fire safety as well. Because if you're running the dust collector and something should happen, let's say you suck up a nail or a piece of metal or something, and it cuts a hole in one of the filters. Now the filter is going to be leaking, so dust is going to get by and go through the fan and exhaust it out. If that happens and all you do is exhaust the air out, you just blow dust outside, you get in a problem maybe with the county for an air permit violation, or you can quickly see it, fix it, and nobody's the wiser. If you're recirculating the air back in, though, all of that dust that leaks just gets blown right back into your building. Now, in woodworking, that's bad, especially bad because you have combustible dust. Now you're recirculating it back in. You're basically blowing in combustible material and depositing it nicely all over your building, especially on like elevated surfaces, like on top of machines, rafters. So in that case, sometimes it's required, sometimes it's not required, but it certainly is a great idea, is you need something in the event that you have a leak in the filters. So traditionally what they do is they have you put HEPA after filters so that after it goes through the filters in the baghouse, goes through the fan, and then you blow in, it goes through a set of HEPA filters that don't really do anything because the dust collectors already captured everything, but they're there in case you ever have a leak in the filters in the dust collector, and they capture everything so nothing gets into the plant. A little riskier, but a viable and reasonable way to do it instead of the HEPA filters is to have a very sensitive bag leak detector or filter leak detector in the ductwork after the filters. So that way, if you get any leakage, it'll go off right away, and you can shut down and go take remedial action to change the filter or whatever it is. Sometimes we can combine that with a abort gate so that if it detects a certain amount of dust coming by, the abort gate will slam shut and open on the top, and it'll blow all the air out to the atmosphere. So you do have a problem, but you will not be blowing dust back into the building in any case. So if you do those couple of things, you can make the recirculating the air absolutely possible. And a lot of our customers do that, and we're able to help them with that. It just requires that extra investment and just makes the system a little bit more complicated. But in places where you have a lot of heating and cooling costs, or you need to really control the humidity inside, for example, I work with a couple of major guitar manufacturers, and controlling the humidity level inside the building is so important that for them it's worth it to have all these extra devices and extra procedures because just dumping all of that conditioned air out into the atmosphere is a huge waste of money. So for them, it makes sense. Have it go back in and add these couple extra safety devices and procedures, and then there's no problem.